Okay, good afternoon. Welcome to our MAT123 course in Abstract Algebra. This is a course offered by LD Woosley Bethany College. Welcome you. Would like to wait for our students to come in. So let's just wait for the students. Some may not join us today, no? Due to some network issues. Nevertheless, we will continue. For recording purposes, we're also live at CBC Ministries online page. Let's just wait for our students to come in. Okay. While waiting, I may wait for them, okay? Okay, what happened to our students? Where they are right now? Ayun, here we go, speaking. Okay, welcome Micaela, how are you?
Afternoon po.
Okay, sige. Dale, I think, has issues with the connection. Isel also part of our abstract? Or not?
Parang hindi na po.
Parang hindi, kayo lang ni Dale. Tama?
Okay,
Kayo lang ba ni Dale ang abstract? Kasi din parang may network issue. Sa problem solving din, medyo ano siya. Okay. Yeah, let's wait for a while. I mentioned already to solve. How many items to solve for the module 1 that I have uploaded, Micaela? Diba I told you to answer something? 10, no? 10. Sige, okay lang. Kasi marami namang items eh. Baka yung ibang matalakay ko pa. Before we move on. Actually, we're not yet on abstract. This is a pre-abstract algebra course. Yung module 0 na yan. So we will finish that today and then next week, start na talaga tayo ng about groups. Yan, yun yung mga concepts ng groups, ng subgroup. Yan. Other things that are weird. Basically weird, but not, hindi naman. Not necessary. Okay. Sige, let's open the word of prayer. Then, tuloy na tayo. Father in heaven, we thank you for this day. Thank you for this opportunity where we could continue on our study. I hope and pray that you will guide us with this important aspect of this introduction to abstract algebra. But we appreciate this and we may think with computation and our strategies in solving, Lord, will be enhanced to this course. I pray, Lord, for Micaela and the rest of the students, the math majors, that they may persevere also in their study and that you may bless them, Lord. We thank you, Lord. Glorify your name. This is our prayer in Christ's name. Amen. All right. So, just hang on with the book that I upload. So, that will be our, I would refer to that. Now, ngayon, I will browse on this. No? I suppose you have read already the book. That's my assumption. So, basically, ang abstract algebra is actually involves integers. No? Kaya meron tayong properties of integer. Much of the abstract algebra concept are actually based on the properties of integer. Ano ba yung mga properties of integer, Micaela, ang naaalala mo? What are those properties of integer you may recall?
They are not fractions po.
Hindi, properties. Saka integer, hindi fraction. Wala pa tayo dun sa rational. Integers lang. Of course, when an integer is equal to itself, what do you call that? What do you call that axiom or property? If A is equal to A, what's that? Kasi we will be dealing with that sooner or later. No?
Identity.
Hindi siya identity. Identity, when used in addition and multiplication, that becomes an identity element. That's possible. But to itself, applying to itself, A is equal to A or A equal to itself, what do you call that? O yan, isipin mo, pang-board exam problem yun. It's a property of a number that's equal to itself. That is A, associative, B, transitive, C, distributive, D, reflexive.
Ano po ulit yung C?
Hindi ko na ulitin, wala ka. Anyway, without the choices, you should answer that. What property of that? What's the property of any integer or numbers in general, but this is specific for integers, whereas it's equal to itself? That is, what? Reflexive. Reflexive yan. Kung makakalimutan yan. So ano-ano pa ibang properties? Symmetric. Symmetric property, meaning if A is equal to B, therefore B is equal to A. Yung reflexive, A is equal to A. Alright? Transitive, A is equal to B and B is equal to C. Therefore, Michaela?
A is equal to C.
Yon, A is equal to C. That's transitive property. Now, if A times the quantity B plus C is equal to Uy.
Hello po.
Uy, mahina ba? Ulit. A times the quantity B plus C is equal to
AB plus AC.
by virtue of
Distributive.
distributive property. Okay, dapat by this time you're confident or even all of you, no? Kasi napag-aralan naman yan sa algebra, I suppose, no? So these are all part and parcel of abstract algebra, no? Yung kaya nga principle ng properties of integer, napakahalaga niya, no? And then of course, we have the well-ordering principle. When you say well-ordering principle, by the definition of the book, it says here that every non-empty set of positive integers contains a smallest member. So there's a smallest member if it's not an empty set, no? Kung di siya empty set, ibig sabihin may pinakamaliit diyan. Okay, so of course the concept of divisibility, we have lectured that before. Previously, the concept of divisibility in terms of a divisor. Yan, so napag-aralan na natin yan. Then that we have what we call the division algorithm, no? The division algorithm is actually, it says here, yan, where A and B are integers, okay. Okay, so it says here where under the division algorithm that your A and B are integers and should be is not equal to 0 or greater than 0. And there exists a unique integer Q and R with a property. So ito na yung division algorithm na napag-aralan natin last time, no? So this is also reflective of the modular arithmetic that A is equal to BQ plus R, wherein R is somewhat between 0 and B. No, hindi siya greater than B. It's always less than B. No, yung remainder mo, because B is your divisor, so therefore the remainder should be smaller than the divisor. If not, no, maling remainder 'yon. No? So dapat yung R mo, remainder, should be less of the divisor. Okay? So yun yung makikita natin dyan. Let's jump to the example here. So hindi ko siya no? So dapat you have read already the material, so we're just passing through, so that next week we'll focus more on introduction to the abstract. Siguro 3 weeks is enough for an introduction. We introduce set theory, we introduce some number theory, and now we are utilizing the book, the introduction of the book, that is chapter 0. So all of this could be used in describing the groups of integers or numbers, no? So that's why we're referring Q as the quotient and your R as a remainder when A is divided by B. Okay? So for instance, if you have A is equal to 17 and B is equal to 5, by virtue of division algorithm, what will be your Q, Michaela? For this example, A is equal to 17 and B is equal to 5. So what will be your Q?
3.
3. And then, of course, obviously, the remainder is equal to 2. Alright? Same as true, assuming that A is equal to negative 23 and B is equal to 6. So it will give accordingly, your Q is negative 4 plus 1. So R is equal to 1. Take note, your R is always less than B, or the divisor. Okay? And then we have here the GCD. We already discussed this last time. The greatest common divisor for all. That normally when the GCD of a number is equal to 1, there are what we call relatively prime to each other. No? Relatively prime. So basically, A and B are non-zero integers, largest of all common divisors of A and B. We denote the integer GCD of A and B. Of course, we have done that in our math octave before. So when GCD is equal to 1, they are relatively prime to each other. Then we could say also, based on this definition, that your GCD is of the linear combination. Tingnan ko nga si Dale, baka okay na sa chat. Wala naman sa YouTube. Wala sa YouTube. So, sinabi niya ano daw siya sa YouTube eh. Bibisita. Dahil lang I have some issues, network issues. Alright, so here GCD, no? So for instance, the proof, I will skip on the proof, Micaela. You could just read the proof. So we'll be digging with more on the examples, how it is implemented. For instance, here there's a corollary. Ibig sabihin ng corollary, it's a subunit of your theorem. No? Theorem 0.2, though I will not be tedious on the numbering. This is dependent on the book, but we could generalize this. So it says here for a GCD, or greatest common divisor, as a linear combination. No? So for any non-zero integers A and B, there exist integers S and T such that the GCD, or the greatest common divisor of A and B, could be expressed as AS plus BT. Moreover, GCD of A and B is the smallest positive integer in the form AS plus BT. So there's an expression here, no? So pwede natin siyang express into the sum, wherein of course your S and T are also integers. So for instance, if you would like to have an example here, sige, I'll pull down my Word document. Ilang mabagal yung atin. Siguro for this more on take home na lang siguro Micaela, yung ating requirements. Nabanggit ko na naman, take home. Puro solve problems siguro. So yung dito at the end of the exercise, meron, and then yung i-upload kung susunod, meron na naman yan. So depende kung saan tayo makaabot. So we'll just be selecting for your, so wag hanggang week 6 siguro ang submission, sa week 6 na lang if we will finalize the number, kasi nga parang ang nangyari, kasi i-discuss din natin yung ibang mga solution, di ba? Remember last time, no, we also solved some problems, no, na nandun. Okay, so we will just finalize it before week 6, no, which will be your submission. So yun na lang, para medyo pahinga ng konti sa abstract. Yun lang, of course, we need to have some participation also. Ayan, babalansin ko ng participation mo every time I ask question, and then of course your take home. So sa take home naman, so pwede ka mag-isip-isip dyan, kasi nga It requires proving. It requires derivation. So that's how abstract algebra works, no? It's more on derivation, proving, no? So ganun siya, hindi siya katulad ng algebra where there's an applied problem. We could just substitute the 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 given to the formula, then presto, lo and behold, you have an answer. But not necessarily in abstract algebra. So you need some derivation and proving skills, no, as needed. Okay, so let's have an example here. For instance, maybe in your mind, can you think of two numbers, Micaela? Two numbers, two one-digit number in your mind.
7, 8.
7 and 8. What is the greatest common divisor of 7?
1.
1. So 1, relatively prime pala, no? Hindi siya pwede sa relatively prime kasi nga pag yung AS plus BT and express mo, hindi dapat may sige, teka. Is the smallest possible integer in the form. Oh, that's the smallest possible integer in the form. Sige, tingnan natin yung mga samples dito. No? Okay, sige. Diyan muna yung natin. Kasi nga, 1 siya, relatively prime. No? So, ayan. For instance, this one. GCD ng 4 and 5 is 1. Basically, they're relatively prime. No? 4 and 10 is 2 because the greatest common divisor is 2. Now, if we will look into this expression of prime factorization, so 2 squared plus 3 squared times 5 and 2 times 3 cubed plus 7 squared. So we know that the greatest common divisor would be 2 and 3 squared. The least exponent, which is 2, and then 3 squared. Note that 4 and 15 are relatively prime. No? Ito yung natin, whereas 4 and 10 are not. Also, yan. We could express that. No? Hindi lang siya confined doon sa positive integer, it could be negative integer as well. So balik tayo dun sa 8 and 7. Kung 8 and 7, 1, pwede pa rin, no? Possible na ma-express. Yun nga lang, yung isang integer dyan ay negative. Tama? So any combination you may think that 8AS plus BT, no, is equal to 1. No, kasi ang GCD mo ay equal to 1. So pwede tayong ngayon, we could always look up a negative integer to satisfy that. Okay, for instance, for 7 times negative 1, and you have 8 times, or perhaps 7 times, 7 times 1, or 7 times negative 1, and then 8 times 1. So both are still integer. So that would result to positive 1. Okay, so any combination that we may have. Okay, makes sense, Micaela. So pwede siya ma-express dahil may negative integers. Now we have negative integers to supply either S or T. No? So yun yung natin dyan. Now the next lemma, which is actually part of the corollary, we have learned already. Can you read this, Blue? If you may still recall, Micaela. Yung expression na to. Anong basa? This one, no?
Hindi ko po maalala.
Kalimutan mo. That is P divides AB. O, di ba? P divides AB. Nandun sa lecture yan. Though hindi ko siya in-upload kasi supplement lang naman siya. No, that's P divides AB. Ayan, in fact, nandyan din naman yan as we go to the slides. So, P divides AB implies that P divides A or P divides B. Alright? Halimbawa, example, 2 divides 8. And we know we have what could be the factors of 8. What? Give me a factor, 2 factors of 8. Michaela.
4 and 2.
4 and 2. So therefore, if 2 divides 8, it implies that 2 divides 4 or 2 divides 2. Yun ang ibig sabihin yan. No, yung lemma na yan. It's possible to distribute P to the factors. Alright? So parang may distribution. So if P is a prime that divides A and B, then it follows. No? So prime. So meron siyang ano dito, no? But anyway, so that divides AB, then P divides A and P divides B. Okay, let's look at some example here. So yung mga proof, readings mo na yan, Michaela, no? So we will not discuss that. Now next to this, aside from the LCD, or GCD rather, and the division algorithm, we also have the fundamental theorem of arithmetic. So let us reiterate this. The fundamental theorem of arithmetic. So iba siya dun sa fundamental theorem of calculus. Iba pa yan. Doon na-touch natin ng konting-konti yon doon sa calculus 2. But here in arithmetic, so meron kang fundamental theorem. No? It says here that every integer greater than 1 is a prime or a product of primes. So yan pumapasok yung prime factorization. This product is unique except for the order which the factors appear. So yung order or yung degree of the prime factorization. So every composite number could be expressed into products of primes or yung prime factorization na tinatawag. So that is if n is equal to P1, P2 up to PR. And n is equal to Q1 up to Qs, then the P's and the Q's are primes, then R is equal to S. After numbering Q's, no? So yan yung makikita natin. Let's look at here. So from there, we could derive the least common multiple. This time, I suppose you know this already, the least common multiple, no? So yan, so yung mga examples natin, least common multiple of 4 and 6 is 12. We know that because this is the least multiple that can be divided by 4 and 6. So least common multiple. And then you have 4 and 8, obviously is 8, 10 and 12, 60, etc. and etc. Then we go to the modular arithmetic. No, yung this will be using this will be using the division algorithm in the form A is equal to BQ plus R. So yun yung kanina nating yung kaninang format natin. So based on this, A is equal to BQ plus R. That will be utilized by modular arithmetic. Okay? So actually maraming application to modular arithmetic, one of which is barcode. Another thing is identifying whether a check is true or not. No? Kung may modify lang doon sa check number or sa credit card number, no? Meron diyang modular arithmetic na ginagamit. No, yan yung isa sa mga sinasabi nating application ito, yung mga modular arithmetic. Or sometimes, to be specific, more on cryptography. Yung cryptography. Alright. So example of which, as we pass by, so yan yung ating mga example. So 3 mod 2 is 1. Now since 3 is equal to 1 times 2, that's Q. Your Q is equal to 1. Q Q times B, no? So, and the remainder is equal to 1. And we could continuously repeat this until such time you have your quotient equal to 0. So, possible yan na magpatuloy pa rin yan hanggang ang Q mo maging 0 na. At ang isa na lang matiiwan yung remainder. So, that could be a continuous operation or process for this case. So 6 mod 2 is 0 since walang remainder yung 3 times 2, no? Ganun din naman yung 11 mod 3. So it could be expressed to 3 times 3 is 9. So far okay na yung modular, no? Nagigets mo na siya, Micaela, yung process niya. Modular arithmetic. Okay, good. So ito yung halimbawa ng example natin. Ayan, ito yung postal check sa money ng US. Sabi niya dyan, if I read. So ito yung digits niya, no? 3953988162. So yan. So ayan yung tinatawag yan, 10 digits together with an extra digit called a check. So the check digit is the 10-digit number modulo 9. So it's using modulo 9. Thus, the number 953 988164 has a check digit 2. So meron kang check digit o yung parang correcting digit of 2 such that the equivalent supposedly of the modulo 9 is equal to 2. No, pag minodulo mo yon, yung eto, sige, bigyan natin ng i-flesh it out using kahapon, Micaela, palpak yung ating I don't know. Hindi pala kayo umakyat kahapon ni Isel, no? Sa Calculus 2. May klase ba kayo?
Sasama po sana ako, so kaya lang may kailangan pong ipasa na may kailangan pong i-video po.
Okay. So, sayang. Anyway. So, kala ko nga, makakasama kayo. So, eto yun. So, yung modulo 9 ang ginagamit niya dyan. Yan, medyo palpak kahapon yung grabe. Yung ating, yung octave natin. So, 3953988164. Kasi modulo 2. Dapat ang sagot mo, pag minod 9 mo yan, equal kay 2. O, yan, oh. Nakita mo, dapat, ang result, 2. When you use modulo 9. Nakita mo, Micaela. Ngayon, pag minodify mo, yung isa man sa mga digits dyan sa check number na yan, o po, sa money transfer number na yan, hindi siya magiging hindi siya 2. So therefore, may problema, either pineke o dinoktor yung dokumento. That's how you check. One of the ways is using modulo arithmetic, where in the last digit 2, ito, yun yung checking digit mo, pero yung minomodulo mo yung first 10 digits here, and normally it's modulo 9. Modulo 9 yung ginagamit. So dapat ang sagot 2. No, pag iba, halimbawa, minodify natin yan. Say, ito, ginawa kong 0. Oh, dalawa pa rin. Nagkataon lang to. Teka, wait. Tingnan natin yung example dito. Minodify niya, 55. Nagkataon lang yan siguro. Ayan, 4 na siya. Naging 4 na. So, ibig sabihin, na-modify yung ating cheque o pineke yung number. No? So meron kahit yung mga check number, yan, mga yan eh. Meron talaga siyang pang ginagamitan siya ng modulo arithmetic to check whether it's genuine or not. And usually it's machine read. No, binabasa ng machine yan, kinakalculate ng machine kung tama yung mga letters o yung numbers, values. And that is one example here. Another is your barcode. So meron ding mga ganyan. Though hindi na natin i-elaborate ng gusto yan. So just you could just read on that example regarding barcoding. Alright, so okay, let's look to another example here, which is example number 6. So sa check, ganyan ang ginagamit. Ayan, mga modulo. So, yan, barcode. Okay, meron tayo. Acknowledging, sino ba yan? Ikaw ba yan, Dale, ang nanonood sa ating YouTube channel? Paramdam ka, kapatid. Hindi ko alam kung si Dale ito eh. Kasi sabi niya, titingin daw siya sa ating YouTube channel. Yan. So anyway, let me see. Let's have some, yan, example number 6. No? Doon hindi ko na siya, drag ko siya ng konti para makita. Okay, anyway, I'll be reading this, or you could open your copy also, Micaela. Consider the statement, the sum of the cubes of any three consecutive integers is divisible by 9. This statement is equivalent to checking that the equation n cubed plus n plus 3 cubed plus n plus 2 cubed modulo 9 is equal to 0 is true for all integers because of the properties of modular arithmetic. To prove this, all we need to do is to check the validity of the equation at n is equal to 0 up to 8. Yan, so may kita natin yon. So yung, say, you think of a number, Micaela, to substitute here. Or sabihin natin 1, 2, 3. 1, 2, 3, Micaela. 1 cube plus 2 cube plus 3 cube. Anong sagot? 1 cube plus 2 cube is 8, 9. And then you have 3 cube, 27. 36. 36 modulo 9. Micaela.
0. 0 po.
0. So, pwede natin improve yan. Okay, another. Sige, 2. Pag 2, 3, 4. 2, 3, 4. 2 cube plus 3 cube plus 4 cube. 2 cube 8. 3 cube 27.
35.
And then, 4 cube. Anong 4 cube? 64. 64 plus
35.
ano, nakalimutan ko na. Ito na lang. May
Plus
meron naman.
35 po.
Sige. Alright, so if you have a 3 cube plus 4 cube plus 5 cube. Halimbawa, ito. 216 mod 216 9. So 0. So in all aspect, no? Pwede nating bakit kaya? Ba't kaya ganun yung property? Palagi mo, why is the reason it's always correct? Bakit kaya? Is it with the property of the numbers? Micaela? What can you say? By your observation, halimbawa, 1, 2, 3 ang ginamit mo. O kaya 2, 3, 4. O kaya 4, 3, 4, 6. 3, 4, 5. And then 4, 5, 6. Pansinin mo yung mga pares na yun. Micaela. Anong meron? Common denominator. 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6. Anong common sa kanila?
Divisible by 3.
Okay. May divisible by 3 at the same time, may partner siya. Yung partner niya, pag kinuha mo yung sum, it will lead to divisibility of 9. Halimbawa, 1, 2, 3. Yung 3. Yung 1 and 2. Pag kinuha mo yung sum niya in terms of cube, 2 cube plus 1 plus 9. 9 yun. And automatic, yung 3 cube is always divisible by 9 kasi 3 squared eh. Doon pa lang sa squared, no, times 3. No? So, mapapansin natin doon, meron kang divisibility by 9 doon. At the same time, meron ka, yung other than 3, yung pag kinuha mo yung sum, divisible pa rin kay 9. So, ganyan yung property niya. Halimbawa, 2, 3, 4. O, yung 3 doon yung divisible. Yung 2 cube, 8 plus 4 cube. What is 4 cube? 64. 64 plus 8. 72. Divisible by 9. Diba? So, kahit anong mong kunin yun. So, kaya by virtue of this modular arithmetic, we could, sabi dyan, modular is occasionally used to show that certain equations have no rational number solution. So, kasi nga, more on integer and modular arithmetic. Okay, another here. So, we will skip example number 7, no? So, for your reading. Ay, logic gates. Familiar ka sa logic gate, no? Kasi may set theory. Diba? May set theory kayo, no? Ito, logic gates. Yan. So, normally, gumagamit siya ng modulo 2. Modulo 2 arithmetic. Since it's electronic, kasi 0 and 1 lang yan. No, modulo 2. Ayan, yung x and y, it's xy, x or y, and x or y, exclusive yun, no? And then the majority. Okay? So those are classic example. Perhaps modulo could be applied to cryptography in terms of these security features of your checks, even ATM and other financial records, even receipts. Some government institutions or department are using modulo arithmetic even in the receipt number. Kaya lang, hindi ko nasasabihin kung anong city hall gumagamit nun. Merong city hall na gumagamit ng modulo arithmetic. No, hindi ko lang alam yung exactong formulation niya para matiyak na yung official receipt na ini-issue ay hindi pinipake. Diba? Normally, pag sa labas ng city hall, may mga pictures dyan. Yan yung may city hall na gumagawa niya. No? At the same time, yung barcode, no? Application din siya. And then sa logic gates in electronics, particular digital electronics, we make use of the modulo 2 arithmetic. Okay? Now, second part of which is actually complex number. I suppose you are acquainted on complex numbers already, as we have discussed this previously. No? Complex number, we know that this in the form A plus BI or J, whichever is appropriate, wherein A is the real part and BI is the imaginary part. Forming what we call, ano nga bang tawag dito sa, ano na to? Anong coordinate system to, Micaela? You still recall? Pareho siyang, mukha siyang Cartesian, di ba? Pero hindi siya Cartesian when applied in complex plane. What do you call that plane? Hindi siya Cartesian plane. Kasi nga, ang Cartesian, parehong real numbers yun, x and y. Ito, x real, y is imaginary. So, that would be the case, how does the plane produce? No.
Sabi mo, complex plane din. Alam ko po yung...
Oo nga, sinabi ko na yun. Ibang tawag. Complex plane. Complex plane siya, pero anong tawag? Kalimutan mo na. Discuss yan. We discussed that actually. Alright, that's your argand plane. Alright? Huwag kakalimutan yung argand, ha? Argand plane. Alright? Or yan yung ano natin. Yan yung plane used for complex. What do you call R? Ang tawag kay R? Anong tawag kay R? Tapos anong tawag kay theta? Parang kakaaral lang sa problem solving yun. Oh. When talking to z is equal to x plus jy or yi, so when you solve for z prime, anong tawag doon? Of course, that's the hypotenuse of the triangle, but you don't refer this to the hypotenuse of the plane or the complex number. It's called the, anong command dyan sa ano? Di ba may command tayo dyan sa ano? Sa MATLAB, no? Assuming we have z sub 1 is equal to 2 plus 3i. Oh, paano ma-solve yung ano nun? Yung R mo, anong ano natin? That's your absolute value. That's your absolute. Oh, that's your absolute value. Yung hypotenuse, sinolve niya agad. Oh. And then yung theta, anong tawag mo? Anong tawag sa theta? Of course, the direction or what the other term? Oh, ano yun? Ano to? Kaya what's that? Command. Oh, ano nangyari, Micaela? Mukhang busy ka. Busy ka ba? Marami ka sigurong iniisip. Hindi mo na maisip. Kakaturo lang natin sa problem solving nito eh. What's the, you call the theta? What you call that? The arg? What's the arg? Yung abs is absolute value. Yung arg, ano yung arg? Micaela?
Sir, nakalimutan ko po talaga.
Naku po, paano kaya yan? Argument. That's the arguments of complex number. Argument. Yung argument mo, ayan. So, of course, radiant measurement yung papakita niya dito. Kaya tuloy, nag-stack tuloy yung octave natin. Ayaw, no? In-enter ko na eh. Ayan, yung argument. In radiant yan. Pag kinonvert mo sa degrees yan, makikita mo yung degree measurement. That's the argument of the plane. Okay, the argument. Alright? So, of course, we could always convert that. Bakit natin kailangan makuha yung absolute sa kayong argument? Because we could convert this. By the way, the x plus y, a plus bi, anong form yan? How do you call that form? Yung x, ano ba, 2 plus 3i, yung kanina? Anong form yan, Micaela? Anong form yan ng complex number? Anong tawag sa form na yan? Yung may x and y component pa.
Rectangular.
Yun, rectangular. Pag kinuha mo yung absolute value sa yung argument, anong mabubuo mong form? How do you call that?
Yung isa po.
Oh, yung isa. Yun nga.
Polar form.
Polar form. Okay, ano pa yung ibang expression ng polar form bukod sa polar form? Yung tinatawag natin na bawa ito, yung radian 0.9828 rads par or 3.606 056 par 0.99828 rads. So that's polar. Pero pwede mo siyang i-convert in terms of exponential. Pwede mo rin siyang exponentiate or we could also use the trigonometric form in terms of sine and cosine. Yan. So siguro pa eventually, no, babalikan natin yan, yung complex na yan. Now, we also have the properties. I suppose you are aware of the properties of the complex plane here. Ayan. So you have the closure. What do you mean by closure? Under multiplication. Pag sinabing closure, when you add a complex to another complex, the result will be, Michaela? Dugtungan mo. When you add a complex number to another complex number, the result will be dugtong. Oy, kapag dinagdag mo yung complex sa isa pang complex, ano ang lalabas na resulta? Kaya
The sum of their sum.
Oo nga, yun na nga. Inulit mo lang yun. Ulit, tanong ko, ganito. Kapag dinagdag mo ang isang complex sa isa pang complex, o sum, di ba? Ano ang magiging resulta nun? Yan ang tanong ko.
Another complex.
Ano, come again? What's your answer? What's your answer? Narinig ko yung sagot eh.
Ano, sir? Another complex.
Another complex. That is closure. Bisa may closure kayo, di ba? Kumbaga sa relasyon, may closure. Kung split talaga, hindi yung medyo-medyo lang. Di ba? Kunyari crush na ayaw, walang ganun. May closure talaga. Alright? Kung split talaga. Pag complex, dinagdag mo sa isa pang complex din ang lalabas. Ganyan din sa relasyon, Micaela. No, di ba? Nakakonect tayo ngayon sa mga relasyon. Pag sinabing wala na kayo, wala na talaga. Huwag nang i-close mo na yun. Kumbaga, ang complex, pag dinagdagan mo ng complex, close sa complex. So, close siya sa complex. Ganon din, kapag binultiply mo ang isang complex sa isa pang complex, it's close to complex. That's why it's called closure property under multiplication. Okay? So, meron din tayong closure under division. When complex divided by another complex by normal circumstance, the result will be complex as well. So, ganun siya. And then, we have this property of complex conjugation. When you say complex conjugation, is just multiplying the complex number by its conjugate, meaning when you reverse the operation of your complex part or your imaginary part. For instance, if you have a plus bi, the conjugate automatically is a minus bi. And that get rid of the imaginary counterpart. If you multiply the complex number by its conjugate, the result will be purely real numbers. O, diba? Sa number 4. Pag tingnan mo sa number 4 yan, it's purely real numbers. Alright? Make sense, Micaela?
Yes.
Okay. Parang lungkot mo ngayon, no? Parang hindi ko ma-sense yung energy mo. Ano ba nangyari sa'yo? Mukhang exhausting, ah. May ano ba? Mayroon bang, are you busy of something?
Hindi naman po, sir. Ganito lang po talaga.
Parang low energy ka lang ngayon. Parang ganun. Low energy. Kasi dati nun, ano eh. Anyway, observation ka lang naman. Baka naman nagkakamali lang ako. Alright. Anyway, so meron ding inverses, no? There's also an inverses. Of course, may inverse siya. And that could be a product. There exists a product such that they're equal to 1. No, yun yung inverse niyan. Yung z, so pwede mong kunin yung inverse ng you could always yung z sub 2 kanina is equal to c sub 1 inverse. Pwede natin kunin yan. So there always exists an inverse. Kaya lang, provided however, merong prohibition dito, no? Of course, not equal to 0, syempre. Hindi pwedeng mag-equal to 0. So, yan. So, we could always raise that to negative 1. So, meron kang makukuhang imaginary na inverse nung nauna. Yung kanina 2 plus 3i multiplied by this one. So, that's the inverse of the complex. So, of course, you could also raise it to power. No? Ayan, meron tayong computation dyan. But of course, we have the octave to do that. No, in fact, pwede tayong, kaya lang kasi pag tumataas yung exponent o yung power, gumagamit na tayo ng properties. We are actually converting this into its trigonometric form. Uy, lumipat ah. Nangyari doon. Ay, tira. We're actually converting it into a trigonometric form. Yan. So yung trigonometric form na a plus bi is equal to r, that is your argument, times the quantity cosine theta, or the absolute value r, no? Cosine theta is the argument, plus I sine theta. So that's the trigonometric form. In fact, it's still a polar form in trigonometric expressions. But when you raise it to n, so magkakaroon lang siya ng implication doon sa cosine. So r raised to n, and then cosine n theta plus I sine n theta, instead of raising again to a more power. Now, yung more power, yung exponent natin. So pwede nang ganito na lang. Okay? And then yung nth root, ganun din. Meron ka rin mga nth root. So ito yung, instead of, we could always express this in terms of its trigonometric form, extracting the root of r, and then you have this particular expression, cosine theta plus 2 pi k all over n. So yung all over n, yun yung epekto ng radical. Itong radical, yung index mo na n, doon, yun din yung n nito. No? Saka to. Okay, dapat theta plus 2 pi k. 2 pi k. And yung k mo should be 0, 1, up to n minus 1. Yan yung ano. Okay, I think we have some sample problems here. Let's go to na. So you just read along these 7 properties of complex number. In fact, ano yan, magagamit natin yan in our, as we advance our discussion. Okay, for instance, getting the sum. So very, ano yan, kayang-kaya natin yan. So you just add the real part and add the imaginary part. For multiplication, you may follow the normal binomial technique in multiplication, multiplying 2 binomials. So that's how we do it. At the same time, for division, the technique that we have here is to multiply it by its conjugate. The purpose of which is for us to get rid of the denominator. So if you would like to get rid of the denominator, imaginary denominator, multiply both numerator and denominator by its conjugate. And the resulting would be just a denominator that's a real number. So of course, still the answer is imaginary pa rin. Yan. Same as true with multiplication and same as true by getting the reciprocal or the inverse, the inverse of a complex number. Yan. Another complicated here is exponentation in example number 10, whereas we need to convert this into its trigonometric form. Okay, trigonometric form. Okay, so bakit 3 pi over 4 siya? Yan ang tanong ko sa iyo. Nung kinonvert yung negative 1 plus I raised to 4, o yung negative 1 plus I muna. Wala pa muna yung 4. Bakit 3 pi over 4 siya? Okay, Micaela? At 3 pi over 4. Of course, this in rods, no? Radian measurement. Micaela? Okay, hint. Nasa anong quadrant ang negative 1 plus I? Nasa anong quadrant? Quadrant 1, quadrant 1, 2, 3, or 4? Micaela? Halimbawa, isipin mo board problem to. Which quadrant this complex number located? Where C is equal to negative 1 plus I. A, quadrant 1. B, quadrant 2. C, quadrant 3. D, quadrant 4. E, none of the above. Sagot. Ayun, parang kumukulo yung tutok mo, Micaela. Ayan, nawala na. Anong sagot? Yan. I-drawing natin yung negative 1 plus I. Kasi minsan, pag hindi mo ma-imagine, dapat i-drawing mo. Yan ang solution dyan. Whenever there is need to reinforce your imagination, you could draw your imagination. Particularly mathematics problem. Now, given negative I plus 4. Ito, sige. Drawing tayo dito. Hina ng word ko. Magal. Ito, drawing tayo. Ay, wala pala yun. Ito. Ayan, di ba? So, ito yung positive natin. So, representing by 1 and negative 1. So, complex plane tayo, no? And then your vertical or y-axis is represented by I and negative I. Ang tanong, nasaan ang negative 1 plus I? Nasaan? Micaela. Nasaan kaya? Ito, negative 1. Point. Oh, ito yung 1. Ito yung I, oh. Anong sagot, Micaela?
Second.
Negative 1 plus I, yan yun. Oh, ang tanong ko, balik tayo sa tanong, bakit 3 pi over 4? Yun talaga yung tanong ko eh. Di ba? Kung babalikan natin yung problem kanina. Ayan, bakit 3 pi over 4? Okay, nandyan sa illustration din yung sagot. Kasi nga, nasa second quadrant siya. Oh, di ba? Meron ka ng pi over 2 dito. Tama? 90 degrees. Eh, kalahati pa nun. 5/4, 45 degrees. Oh. So, ano lahat yan? 135 degrees lahat yan. Alright? That's why it's 3 pi over 4. Okay? Kasi nasa second quadrant. Yun yun. Yun yung logic bakit 3 pi over 4. Alright? Kaya nung kinonvert siya sa polar trigonometric form, of course, yung absolute value mo, square root of 2. And then yung 3 pi over 4, that is the argument or the direction. Then you are expressing it raised to 4. So by virtue of the theorem that we have a while ago, ito, didistribute mo lang doon sa angle. 4 times 3 pi over 4. So cancel siya, no? Ito rin, I sin 4 times 3 pi, cancel din yung 4. So may iwan, cosine 3 pi plus I sin 3 pi. Tanong, what is cosine 3 pi? What is cosine 3 pi? Ano? Micaela, what's cosine 3 pi?
Negative 1.
Negative? Pakiulit yung sagot.
Negative 1.
Negative 1. Bakit negative 1? Ano ba ang 3 pi? Ano sa degrees yun?
180.
Ha?
180 po.
180 pi lang. Pag 3 pi,
360 plus
180, 540. So, ulit na siya. Kaya yung 540 minus 360, 180, as if 180 degrees lang. Ang tanong, nasa negative 1 yun ng x-axis. So, therefore, negative 1. Automatically, yung sin 3 pi, anong sagot? Anong sagot ng sin 3 pi?
plus 0.
0. Yan. Cancel na yon. So 4 times negative 1 is negative 4. That's the answer. Alright? So yan yung, isa pa, yung cube root. Ito naman, so this time, pag in-exponent mo, multiplication lang sa angle. Ito naman, division sa angle. Pero, ang idea kasi ng cube root, hinahati niya yung buong kabuuan, sa ilang roots. So kung meron kang cube root, may tatlo kang paghahati-hati doon sa angle mo, no? So kaya magkakaganito. So yung in-express mo, yung I is equal to cosine, kasi I is 90 degrees, di ba? Cosine pi over 2 plus sine, of course, cosine is 0. Yung component lang na matitira dyan, yung sa I. No, I times 1, it's I. So, in-express mo lang in trigo form. And then what else? Then, ano mangyayari dito? Hinati mo sa tatlo. Kasi hinati mo sa tatlo. Dapat hatiin mo siya sa tatlo. Cube root. Ayan, hinati mo. Kaya yung pi over 2, naging pi over 6. Divided by 3. In effect, ano yung naging epekto sa kanya doon sa angle? Ito, kinonvert niya na sa rectangular form. So, cosine pi over 6, alam natin, square root of 2 over 2. Sine pi over 6 is 1/2. So, binalik mo na siya. Ngayon, anong susunod na root? Anong increment mo? So, sa loob ng sa pi of 2 pi, yung buong bilog na 2 pi, hatiin mo sa tatlo. So, obviously, you will increment 2 pi over 3 for each of the root. Starting from pi over 6, then you will add another 2 pi thirds. 2 pi thirds. Pag you get the sum of this, so saan na siya ngayon? So magiging yung pi over 6 plus 2 pi thirds, Micaela, what's the answer? Yung pi over 6 mo, dagdagan mo ng 2 pi thirds. By the way, 2 pi thirds is 120 degrees. 120 degrees plus 30 degrees, it's 150. Diba? 150. So kung 150 siya, anong pagkakaiba ng pi 6 o 30 degrees sa 150? Micaela?
Kaiba po sila ng quadrant.
Siyempre. Ano pa? Yun lang ba? Ito yung 30 mo eh. Ang 150 mo, ito. So, eksakto siya. Eksaktong salamin. Replika. Replika yan, Micaela. Ayan o. Hindi pa ganitong mouse ko, hindi ko makontrol. Yan. So yan, 150 yan. Eksaktong replika. Parang nanalamin si 30 degrees. Ano lang kinaiba? Yung Y or yung X? Kaya
X po.
Yung X. Naging negative yung X. Kaya pag tinignan mo dito, negative square root of 3 over 2. Alright? Pero pareho lang yung Y component. Ngayon, dinagdagan niya uli ng 2 pi thirds. Naging 4 pi thirds na. So, ibig sabihin, yung 150, dinagdagan mo pa ng 120. Anong kinalabasan? What's the answer? 270. Saan yung 270 degrees? Ano yon? Ano sa quadrant yon? Sinong matatapatan ng 270, Micaela? Ito yun.
If I...
Parang pangit yun. Ipit kasi yung mouse ko. Hindi ko ma-drawingan ng gusto. Yan, ito. Hinati mo kasi sa tatlo yung buong bilog. Yung una mong root, 30 degrees. pangalawang mong root, 150, that's your R number 2, and then yung R number 3, that's the last part, no? That's your 270. This is your R number 3. O di ba hinati mo sa tatlo? Hating-hati sa tatlo yung bilog. Kaya whenever you would like to extract the root of a complex number as if you're dividing the entire plane, quad-argand plane into different parts depending on the index. If you're square root, you just chop it into 2, cube root, 3, fourth root, 4, etc. and etc. So for this case, 270 siya. Sakto yan. Saktong 1/3, no? Yung portion niya. Ay, kaya natira, I na lang to. Di ba? I na lang to, no? Negative I. Ayan. So negative I yung sagot niya. Okay? Okay, question, clarification. Though we're just discussing this by passing, no? We're not really into an in-depth study since this is a preparation to our discussion of abstract algebra, particularly groups. No, we'll be discussing groups by next week. Introduction to groups and groups. Though we will still touch sets, no? Yung mga ibang mga yung mga ibang mga dapat pa nating pag-aralan. Though I will be uploading already the module. No, yung mga notations, no? Though may kaibahan lang ng konti yung ating pero upload na natin 'yan. So meron ulit tayong introductory portion doon. So, introduction and then so for groups. All right. Now next, mathematical induction, no? We already I suppose you have an idea on mathematical induction, Micaela. That's the next question here, mathematical.
So, sir, ngayon ko lang po siya narinig.
Ngayon mo lang narinig. Okay. Thank you. So anyway, we will pass by here, mathematical induction. Pag sinabing mathematical induction, it is actually proving a theory. No? Assuming that the initial state is true and all throughout the values of n is true, therefore n plus 1 is true as well. So mamaya ipapakita natin yan. So let S be the set of integers containing A. So yung set mo may integers containing A. Suppose S is a property that whenever some integer n greater than equal A belongs to S, then the integer n plus 1 also belongs to S. Then S contains every integer greater than or equal to A. So may mga ganyang pagbigay tayo ng halimbawa. So ito, let's look, no? Though hindi mo makita, babasahin natin, no? So that is we use induction to prove a given straight edge, a compass or a unit length, no? So that's induction. We can construct a line segment of length square root of n for every positive integer n is equal to positive integer n. For the case that n is equal to 1 is given, now we assume that we construct a line segment that is the length of square root of n. Obviously, that's equal to 1. Then use of a straight edge and compass to construct a right triangle with height 1 and base square root of n. The hypotenuse of the triangle is n plus 1. So by induction, we can construct a line segment of a length square root of n for every positive number. So parang ganito yung ginawa niya. No? Analogy lang to. Actually, analogy lang yung ginamit dito. So assuming you have n or 1 at n is equal to 1, then you have any value of n here. So what would be your, or square root of n, I would say, no? A line segment equal to square root of n here. So what would be the length of this hypotenuse, Michaela? Okay, what's your answer? So this is basically square root of n plus 1. And n is true. If this is true, is true. Itong konsepto ng mathematical, yung initial stage niya dapat totoo. Then, if this is true, therefore, this is true also. So, true din siya. So, ganun yung mathematical. Meron tayong ina-assume na initial value normally is equal to 1. Then, i-assume natin nga throughout values of n. Therefore, n plus 1 must be true also. If n is true, since n is true, n is equal to 1 is true, therefore, for any values of n that's true, it follows that n plus 1 is also true. Yun ang mathematical induction, Michaela. Okay, so let's look some other sample here. Yan. So another example is this theorem, no? Mahirap i-pronounce tong French word na to eh. Yan. Yan, we use induction to prove the positive integer n. Yung kanina to, yung sa sa exponent natin ng trigonometric form. Yan, yung papatunayan mo for real value theta, cosine theta plus I sine theta squared is equal to n theta. Sige, let's assume n is equal to 1. N is equal to 1, what would happen? If n is equal to 1, and we will substitute that n is equal to 1, what would happen? Oh, sige, ano natin? Cosine. So, what would happen here? So, pareho lang, di ba? Kasi raised to n, raised to 1, mawawala yung exponent dito. Yun naman sa right side of the equation, magiging theta lang. Tama? Michaela, tama siya on the initial value if n is equal to 1. Obviously, this is true to n is equal to 1. Now, if n is equal to 1 is true, we could assume that for any value of n is true. Therefore, we could prove that n plus 1 must be true if n is true. Saan ang galing yung assumption na yun? Kasi meron tayong initial value na n is equal to 1 is true. Therefore, if n is true, n plus 1 value must be true. Magets mo ba, Michaela? So, ganun ang mathematical induction. Nag-a-assume muna tayo ng totoo. No? At mapapatunayan natin yun sa initial value na totoo nga siya. Therefore, we could assume it to any value of n. And if this is true for any values of n, therefore, it must be true for n plus 1 value. Okay, ganito ang nangyari dyan. So, kung totoo siya sa n is equal to 1, ngayon, pwede nating subukan si n plus 1. No, pag sinubukan natin si n plus 1, na ito'y totoo dito, no? So, yung n, so ito, n plus 1, ito, raised to 1. So, pwede natin kopyahin tong cosine theta plus I sine theta. So, we could assume that this is true, not true theorem. Apply natin yan, cosine n theta plus I sine n theta times this assumption. No? So, what would happen? So, pwede tayo magkaroon ng cross multiplication dyan. No, kakaroon tayo ng middle term na mahaba-haba. Okay. So, yan. Ngayon, gagamit ka ng trigo identity, Michaela. O dito, ito yun, no? Gagamitan natin ng trigonometric identity yan. Yan. Now, using trigonometric identity of cosine alpha plus beta and sine plus beta. Yan. We see that the last term cosine n plus 1 theta plus I sine of n plus 1 theta. No? So magkakaroon tayo ng mathematical formulations dyan. In fact, siguro solve natin to using using octave, no? Titingnan natin kung tama siya. So, symbolic tayo. So, kung assume natin na totoo yun, so cosine x ay 2. Okay, 2. I-square natin. So, ang magiging impact niyan dito, dapat maging 2x yun. Tama, Micaela? Okay, tingnan natin. Yun, no? So, 2 times. Parang ginanon niya. Teka, wait. Hindi natin makita ng gusto dito. Ganun lang. Simplify. Ito na naman tong si ano eh. Ayan. Ay, malalong lumala. De, pero ito exponential kasi to, Micaela. Exponential form siya ng trigonometric form. Exponential form siya ng trigonometric form. No, kasi nga, we know that yung exponentation nito, ito mismo, ito, magkatumbas yan eh, saka to. Yung e raised to ix, magkatumbas yan. Of course, yung squared nandun. No, so, parang inequate niya. So kung titingnan natin yung trigo identity nito, so magkakaroon ka ng sin, cos, sin, di ba? Parang gano'n, no? Tama ba? Micaela, cos, sin, sin. Cos, sin. Tama, Micaela? And then, sin, sin. Itong sin, sin, ito yun eh. So, magkakaroon ka ng n plus 1 dito, no? Para kang sin x, cosine y, plus sin y, cosine x. Tama? So, ang nangangahulugan, anong ano niyan? So it's the sum. And the sum of n theta plus theta is equal to n plus 1 theta. Pinactor out mo lang. Kaya lumabas tong sin n plus 1 theta. Ito naman sa cosine, cos, sin. Anong katumbas niyan? Cosine x plus y. So, n plus 1 theta. So, ito naman, ganun. So, ibig sabihin, nangangahulugan kung n plus 1 ito, yung exponent mo, at lumabas dito, n plus 1 din, tama siya. By mathematical induction. Ganyan mag-prove ng mathematical induction. It's an indirect proof, actually. Alright? Question, Micaela? So, you have problems on this, on the exercise. Maraming mga problems tayong masosolve dyan. Okay, then we have the second principle of the first principle. Yun nga, we assume that n is equal to 1 is true. If to prove it's true, then we assume that all values of n is true. Then it must be true for n plus 1 value as well. That's mathematical induction. Now, the next is the second principle. It says here, no? Let S be the set of integers containing A, suppose has a property that belongs to n, that n belongs to S whenever every integer less than n and greater than equal to A belongs to S. Then S contains every integer greater than or equal to A. Alright? So ito, titingnan natin yung example number 13. So yan, at A is equal to 2, to prove the existence portion of fundamental theorem of arithmetic, let S be the set of integer greater than 1 that are primes or products of primes. Clearly, 2 is an element of S. Now, we assume that for some integer n, S contains all values of integer with 2 less than equal k less than n. We must show that n is element of S and n is a prime. Then n is element of S by definition because we have shown that S is a set of integer and prime is an integer. If n is not prime, then we can be written in the form AB. So these are more on proving, no? Though we are not really focusing on proving. So pag-practicean mo rin, Micaela, yung mga example nito sa likod. No? Though we don't have much time in dealing with this. No, kasi nga more introductory to. Then another concept is equivalence relation. So nakita na natin dun sa modulo, no? Modulo arithmetic, yung equivalence relation, na pwedeng possible na do magkaiba sila in terms of modulo, yung kanilang remainder ay magkatumbas. So therefore, there are equivalent one to another. That's how we define equivalence relation in terms of the modulo relationship. Now here is the definition, equivalence relation, such that set S is set R of ordered pair or real numbers, pairs of elements such that AA is element of R. So ito yung sinasabi natin kaninang reflexive property. A and A, meaning in itself. There's another way of writing A is equal to A. That's reflexive property. Another is that A and B, element of R, implies B and A, elements of R. That's what we call symmetric property. And it follows also the transitive property, AB element R and BC element R. Therefore, AC element R. So that is transitive property. So these are actually equivalence relation. Now, there are suggested symbols for equivalence. So, yan yung pwedeng itong congruent. Actually, hindi congruent. Approximate, mga ganun. So, itong middle term ang medyo ano. Ito naman, approximate. No? Parang ganun. So, anyway, so pwede nating equivalence class. Pwedeng any symbol ang gamitin dyan. Okay, let's look at another parameter here. Okay, so we have example number 15. Let S be the set of all triangles in a plane. A, B, element of S. Define A equivalent to B. If A and B are similar, that is A and B have corresponding angles are the same, then the symbol here is an equivalence relation on S. So equivalence, no, is yung congruence, no, pwede nating i-apply yung congruency as far as the angles as well. Okay, and then example 16 here. Okay, let S be the set of all polynomials with real coefficient such that F and G are elements of S. Define F congruent or similar or equivalent to G if F of prime or derivative of F is equal to G of prime or the derivative of G. So then that symbol tilde, that tilde symbol is an equivalence relation on S. Since two polynomials with equal derivatives differ by a constant. No? So alam natin yung pag kinuha natin yung antiderivative noon, magkakaroon ka ng constant. So yung constant, maaaring magkakaiba-iba, but yung derivative nila pare-pareho. There another mode example here, no? So maraming example dito. Okay. Na pwede mong basahin. Basa-basa din, Micaela. You really need to read kasi actually ang course na to normally for 1 year ang abstract algebra sa totoo lang. But we will have a fast track on basic concepts of abstract algebra. Starting next week, we'll be discussing groups. Yung mga groups na yan. So, i-upload ko agad yung ating reference text. No? Okay, let's look at the example here. No? So, marami example. Siguro, pwede nang basahin dito. Now, partition. A partition of a set is a collection of non-empty disjoint subset of S whose union is S. Yan. So, yung union nila ay S. Yung buong set. Figure 06 illustrate the partition. No? So, yung nakikita natin dyan, yung partitioning. Though they are not related one to another, but the union would be the entire S. So, yung set 0, 1, 2, 0 is just 0. It's not negative or positive. 1, 2, 3 is a positive integer. Then, negative 3, negative 2, 1, etc. is a negative integer. This constitute the set of integers. So, of different partitions, but constitute S. Partition of S. No, pwede yan. The set of non-negative integers and the set of non-positive integers do not partition an integer since both contain 0. Kasi meron siyang intersection. Dapat walang intersection. No? Kasi non-negative, that includes 0. Non-positive, that is negative. So 0 is a non-negative integer by definition. So we never define 0 as a non-positive. It's a non-negative integer. So dapat, pag partition, walang intersection. Wala ka dapat intersection. Then equivalent classes partition. So meron din tayo dyan. So equivalence classes of an equivalence relation on a set S constitute a partition of S. Conversely, of any partition P of S where is an equivalence relation on S, whose equivalent classes are on the elements of P. Ayan, magkakatumbas yung elemento. Yung elemento ni P na partition ni S. Okay, no? Next. Napapasadahan ko na ito, Micaela. Please bear with me, no? Because we need to finish this module by today. And then next week, ano na tayo? Formal study na tayo ng groups. At iba pang mga ano. Micaela, tatandaan mo itong symbol na to. That's function or mapping. No, lumalabas sa board yan eh. Naalala ko yan. Yan, function or mapping from set A to set B is a rule that assigns each element A of A, set A, exactly one element of B. So that's one-to-one correspondence. This is called the domain of P. And B is called the range of P. So kung domain ang tawag sa kanya sa A, ang tawag sa kanya ay, and B is the range of P. If P or the Greek letter P assigns B to A, then B is the image of A under P. The subset of B comprising all images of elements of A is called the image of A under B. So siguro magkaroon tayo ng konkretong example dito. So yan yung visualization yan. So A to B, you have A to B, that's P. And then itong ps, tama ba? Greek letter ps. PSI, no? Tama? Tama ba yan, Micaela? PSI to, no? Ito. Matawag dito. PSI siya, no? Ito naman, PHI. Tama? Greek letter, no? Ayan. So, pwedeng diretso or katulad niya, no? Composition of and P is a mapping from A to C. So, ito yung mapping mo from A, B, and C. So, parang diretso. Meron kang component ng P, function of P, and function of C. C. Yan, PSI. No, this is your A. So, composition of functions P and C. Okay, parang yung onto. F onto G. Parang ganun. Yung POG. Diba yung POG? F of G of X. Normally, we put it in a circle. F of G of X. Sige, ito yung classic example nito for visualization purposes. So, if your F of X equal to 2X plus 3 and G of X is equal to X squared plus 1, what is F onto G at X is equal to 5? So that would correspond to F of G of 5. So yung FG or POG dapat to nakalagay dito. No, F of G is POG of 5. So therefore, yung G of 5 muna, kung solving mo muna yung G of 5, that is 5 squared 25 plus 1 is 26. Then F of 6 now, F of 26, that is 52 plus 3 is 55. Yan. So, ganun siya. Kumbaga, ito yung function mo, inilagay mo yung F of X dito, tapos G of X mo doon. F of G of X na siya pagdating dito sa pangatlo. So, parang ganun to yung physical presentation nito. Ngayon naman, yung G of GOF naman, G of 5, baliktad naman siya. G of F of 5. So kung 5 to, 10, 13. 13, G of 13, we have 13 squared is 169 plus 1, 170. More generally, POG of X is equal to F of G of X. Alright? So ito naman, more on generalization. No? So walang value na binigay. So pwede kang mag-generalize dyan. So G of X is X squared plus 1. So ito ngayon, i-substitute mo dun sa X ng F of X mo, which is 2 times X squared plus 1 plus 3. So simplify, that would be your generalized POG or F of G of X. Ngayon, ganun din naman yung GOF. Yung GOF o yung G of F of X. So, ganun din siya. No? Halos ganun din yung procedure. Note that the POG is not the same as GOF. Okay? The FG is not the same as GF. They're not symmetric. Alright? So, those are example of mapping. So, this correspond a one-to-one function or one-to-one correspondence. Yan. A function P from a set A is called one-to-one if for every A sub 1, A sub 2 element of A, that you have your P of A sub 1 equal to P of A sub 2 implies that A sub 1 is equal to A sub 2. Just like this one, there's a correspondence between these two. No? Yung A sub 1, yung P sub 1 correspond, A sub 2 correspond to P of A sub 2 here. So, ganun din dito. So, ito, 1:1. Itong yung C is not 1:1 kasi meron siyang, so equal kasi yung P of A sub 1 and C of A sub 2. Hindi siya distinctive. So, hindi siya 1:1. So, we have the definition of a function P from set A to a set B is said to be onto B if each of the element B is the image of at least one element of A. At least one. So, at least one may image. So, ito, if each element of B. So, dapat nakasalalay kay B. Dapat yung B may elemento doon sa, may imahe siya doon sa A. Kung may kulang, hindi siya onto. Ito, onto to, kahit may overlap pa. o merong commonality. Basta lahat ng elemento ay image doon sa A mo. So ito naman hindi kasi merong nahiwalay. So it's not onto. Okay? So next to this, we have properties of function. Again, this will be useful in our study. First is your associativity. You have your gamma times beta times alpha is equal to gamma beta times alpha. That's associativity. So meaning given function alpha, A to B, beta, B to C, and gamma, C to D. So yun yung mga onto o yung function. No? So meron kang associativity. If A and B are 1-to-1, then gamma or beta alpha is 1-to-1. So yung product. So kung may 1-to-1 papuntang beta at may kay gamma, yung product nila mula dun sa original ay 1-to-1 din. If alpha and beta are onto, therefore beta and alpha onto also. So number 4, if alpha is 1-to-1 and onto, then there's a function alpha, inverse alpha from B such that inverse alpha times alpha of A is equal to A for all A in A, or the inverse of alpha, A times inverse of alpha B is equal to B for all values of B. So yung mga proof na yan, I will leave it to you. So we have sample here. Kailangan na natin ano to kasi para by next week separate. No? Though I may have let me see if I could have additional lectures afterwards. No? Para mas maano na natin. Konti na lang naman to. Just to introduce. By the way, I might change the textbook that we are using. So medyo ano kasi I realize ginagamit din sa graduate school yung reference text na. So I might choose an undergraduate text, no? So babaguhin natin yung doon yung content di naman ganun pa lang pero yung book reference natin baka baguhin. Okay? So here, so we have an example 23 here. So Z denotes the set of integers, R is the set of real numbers. Tatandaan mo yan, Micaela. Normally, ito yung ginagamit na symbol. Z is for integers, R is for real numbers, N is for non-negative integers or what we call natural numbers that includes 0. No? And then the following table illustrates the properties of 1-to-1 and onto. So kapag ang domain mo, ang range ay, say these are example, no? So to verify that x to onto or 2x cubed is 1-to-1 in the first two cases, notice that if x cubed is equal to y cubed, we may take the cube roots of both sides of the equation to obtain x equal to y. Clearly, the mapping of z to z given by x to x cubed is not onto since 2 is a cube of no integer. So kasi yung dapat integer no? So kung anong elemento nung isa, halimbawa 1, 2, 3 yung isa, 1, 2, 3 din yung isa. Eh pag 1 cube pareho, pero pag 2 cube iba na. 8. So hindi yung 2 hindi pwedeng maging cube. Na-gets mo, Micaela? Kaya hindi siya magiging onto. Though pwede siyang correspondingly. So 1 corresponds to 1, 2 corresponds to 8, 3 corresponds to 27. So pero hindi lahat nung nasa kabila ay pwedeng maging cube. May nilagpasan tayo. So 1 cube, 1. 2 cube, 8. So yung 2 to 7 nalagpasan mo. O di ba hindi pwede yun sa onto? Yung kanina no, yung nasa natin. O not onto kasi nga halimbawa ito yung sets of integers mo 1 hanggang 8. So yung 1 pasok. Tapos yung 2 cube 8 pasok. Pero yung 2 to 7 dito sa kabila hindi na. Wala siyang correspondence doon sa kabila. Gets mo, Micaela, yung result. Pero 1 to 1 siya kasi kada value ng x may corresponding value of y. So 1 cube, 1, 2 cube, 8, 3 cube, 27. Pero yung ibang mga element nito ng set of integer hindi nagamit doon sa una. So therefore, siya ay 1 to 1 pero hindi siya onto. Okay? Make sense, Micaela? Ganun yun. Pagdating sa integer. Pagdating sa integer. Alright? Hindi kasi nagamit. Okay? Question? Sa integer, pinag-uusapan natin ang integer. Z as an integer. Question, Micaela? So, doon pa lang tayo sa una. Domain of range. So, comparing x and y. So, yung kada values of y, may kada values of x, your domain mo, may corresponding values of y. On 1 to 1 yon. Pero hindi siya onto. Kasi, hindi lahat ng values of y, cube. As far as being an integer is concerned. Okay, question? Okay, how about this one? Real number to real number. Ito, real number. That includes rational and irrational number. So therefore, meron siyang walang problema dun sa kanyang 1 to 1. So 1 to 1 niya, may correspondence. Yes, yung onto ba meron? Possible? Yes, kasi kahit yung 2 dun sa kabila, pwedeng maging cube. Cube root of 2, you have a corresponding value to others kasi hindi naman siya integer, real number. It could be decimal, it could be fraction, it could be an irrational number. In fact, cube root of 2 is an element of x. Tama? Element siya ng x kasi real numbers. Okay? Kilala? Unlike yung sa integer, talagang whole numbers lang yan. Hindi ka pwedeng mag-fractional dyan o iba pang any other. It could be whole numbers only. Na yung iyong onto, maaaring wala doon sa x. Parang na-bypass mo siya katulad niya, 1, 8, 27, etc. So yung in-between elements, wala. Pero itong real number, pwede. Kasi pwedeng magkaroon ng irrational number yung real eh. Real numbers eh. Pwede ba, Micaela? Pwede magkaroon ng cube root of 2 ang x. O yung domain mo. Pwede ba? By the way, this could apply for both negative integers or positive. No? Oh, na-DC ka. So, nasa pangalawa na tayo, Micaela. Nagets mo ba bakit 1 is to 1 yes, onto is yes? Kasi real number siya that contain even non-integers. So halimbawa, yung cube root, kung yung y is equal to 2, anong value na sa x? Cube root of 2. Ang tanong, meron bang cube root of 2 sa x pag real number?
Meron.
Meron. Unlike yung pag z, wala. Hindi pwede yun kasi integer lang eh. Okay, kaya wala siyang onto. Pagdating naman sa R, x corresponds to x cube. Either positive or negative to, no? No? Ito naman, yung sumunod. So pareho siyang yes. So yung ano naman, yung x corresponds to absolute value. X corresponds to absolute value of s, meaning x could be positive, for z is integer, but for n is natural. So magiging value niya is natural number. Ang tanong, may 1-to-1 correspondence ba siya? Integers.
No.
Bakit walang correspondence? Kasi it could be both positive or negative. Pwedeng halimbawa, 3, absolute value of 3 is 3. Negative absolute value of negative 3, 3 pa rin. So walang 1-to-1 correspondence doon. Though meron siyang onto. Possible yung onto. Kasi yung element nung nasa y mo, no, sagot doon sa ano. So hindi ka nag-bypass. Hindi katulad ng cube x to x cube eh. So eto, yes, may onto ka. Pero wala kang 1:1 kasi nga sa lawahan, pwedeng positive negative yung sagot mo. O yung x mo, pwedeng positive negative. No, pero yes, for onto. Etong crucial kapag integers x to x cube. X squared pala. Sige, ipag-isipan mong maigi. X to x squared, bakit no ang 1-to-1? Bakit no?
Kasi po sir yung negative po pag ini-square.
Pwede. So it could be positive or negative. Squared, positive pa rin. Kaya 1:1, hindi siya 1:1. Hindi rin siya onto. Bakit? Katulad yan ng cube, may mga mababypass na integer doon na hindi kabilang doon sa function ng x. Di ba? Parang yung dahilan din kanina sa x cube. No siya kasi may mga mababypass. Halimbawa, for the squared, 1, 4, 1, 4, 9, 16, 27. Paano yung mga in-between? So, hindi na siya kabilang. So, therefore, hindi siya onto. Okay? Nagets mo, Michaela? Sana i-review mo to. Magandang table to. Magandang table yan. So, based on the definition. Anyway, the explanation is there. Oh, ito na yung mga exercises natin. So far, ilan na ba yung nasagot mo, Michaela? Ito na yung mga exercise natin. Maybe we could, ano na yung nasolve mo dito? Hindi ko nga alam paano piliin yung susolvin mo dito eh. Di ba sabi ko, ikaw na pumili, no? Tama? Kayo nang pipili? Ng 10.
Mga di pa po.
Siguro, hindi na ako magsasagot dito para baka mapili mo yung sasagutin ko eh. Any 10 na hindi pa natin na-discuss. Ito, ang dali nito. 7 raised to 1,000. No? Ito, yan. No? O, di ba? Kayang-kaya mo sagutin yan. Ito pa. Yan. No? Lahat yan, sagutan mo na. Lahat ng mga may modular arithmetic. Ito, sa complex naman. Ganito, Michaela, siguro representative ba? Ang hint ko sa representative ng kada topic natin. So, kung 10 yan, meron kang kukunin sa integers, meron kang konti sa modular arithmetic, may konti ka sa complex, tapos mathematical induction, and then function na lang siguro. So, tagdadalawa siguro, Michaela. Okay lang ba? Dalawa sa integers, properties, dalawa sa modular arithmetic, dalawa sa complex number, dalawa sa mathematical induction, at dalawa sa functions. Isama mo na equivalence relation doon. O siguro tag-isa. Isa sa equivalence relation, saka isa sa functions. Or
Kailan
math.
po, sir?
Ipapasa ito sa week number 6. So, iipon mo lang muna. Ipon lang siya, isang submission na lang sa akin sa week number 6. So may time ka pang gawin na kaya nating tagtatatlo. Okay na siguro, Micaela. Pwede pa pag tagtatatlo? Kasi may time ka naman eh. Ngayon lang, dadagdagan ko lang yung kada week ng iba pang mga... Siguro tagtatatlo, baka... Hindi, sige, okay na yan, tagdadalawa. So, dalawang integers question, dalawang modular arithmetic, dalawang complex number, dalawang mathematical induction, isang equivalence relation, at isang mapping. O, 10 yun. Okay na. So, of your own. You choose your own problem to solve.
Sa prelims po yun, sir. Hindi siya weekly.
Wag na weekly kasi isang pisa na lang para isang checka na lang. Isa na lang. O gusto mo may weekly pa bukod dun sa ano?
Ay, hindi po. Akala ko po, sir, yung sabi niyo po last week.
Hindi, pero kada linggo, ganito, kada week, magdadagdag ako ng gagawin mo. Yun ang ibig sabihin. Na ipapasa pa rin sa week number 6.
So this week po, sa diniscuss po natin 10, ganun po.
Ito mismo. Kasi mag-upload na naman ako ng new material eh. Doon na naman ako kukuha ng panibagong exercise.
Okay.
Isa lang to dun sa module. Siguro makaka-4 na module tayo or 3 ngayong prelim period. So kada upload ko, meron siyang exercise sa likod. Ganun yun. And then, siguro, titingnan ko, yung mga examples ko siguro, iba na lang kukunin ko. Or perhaps I could just discuss the example of the book that I'll be uploading. And then you will choose again. Now, depending on the questions. So for the meantime, ito muna. 10. And then next week, baka dagdagan ko uli ng 10. And then hanggang naka-week number 6 tayo. Ayun, so ganun. So ganun lang yung mangyayari. So siguro, yan na rin yung yung submission mo. Siguro yung participation ngayon, walang problema. All of those are taking account. No? And your participation, no, kaya palaging maging handa ka lang. And then yung bulk, of course, your submission. So dapat talagang yan. Ayan, matuwa ako dun sa result. No? Kung perfect yun, di pwede ka ma-perfect sa prelim period, di ba? Walang problema.
Yung mga nasagutan ko po, iipon ko lang po siya, tapos isi-send ko na po siya by prelim na lang po.
Oo, sa week doon sa exam week mo na ipasa. Sabay-sabay na. Kumbaga natapos ka ngayon, wag na yung maraming submission para isang checkan ko na lang. Tapos gagawa uli ako ng form sa classroom natin, doon mo i-attach yung file.
Okay.
Ganun na lang siya. So at least may time ka pa na i-rectify yung ginawa until such time. Okay? Yun lang, madadagdagan na siya madadagdagan. So dapat inassume ko na tapos mo na this week yan, and then panibago na naman by next week. Actually, i-upload ko na siya mamaya or tomorrow. Pwede mo lang simulan yung kahit hindi pa natin dinidiscuss. No, siguro mag-a-assign ako ng exercise ulit sa likod. Mamili ka na dyan ng gusto mong solve. So ganun lang siya.
Okay po.
Okay? So para may time ka kasi ang abstract algebra talaga proving yung mga proof, no, yung derivation, it takes time. Hindi siya pwede sa quiz or exams. Hindi pwedeng ganun. Siguro pambalansi ko, pambalansi ko, may online exam ka pa rin pala, nakalimutan ko. Pambalansi lang yun. Gagawa pa rin ako ng multiple choice. Pambalance ko lang yun. Okay, but don't worry, it will be easy. Multiple choice. Dito rin, sa kung ano yung lecture natin, mag-multiple choice lang ako dyan. Yung pambalansi natin. And that could be taken anytime during the exam week. Okay? So, yun lang yung pambalansi. Mabukod dyan sa take home. Okay, Micaela. So, yan. So pwede mong though hindi ko muna in-upload yung buong book. At I won't kasi baka masya ka lang sa librong ito. So I might change a reference text by next week. Though to valid na tong natin, valid na siya. for until andali lang, I need to switch my window. Sige, konting discussion na lang tayo. Konti na lang naman to para pag-upload ko ng module 1, okay, dali lang. Ay, mali ako. Hindi siya pala na-configure. Still under section 0. I will be immediately uploading this material with the not just the this is just the lecture but the chapter itself of the book. So medyo rigorous kasing lecture notes nito. So, pero i-highlight lang natin yung mga main ideas ditong lecture note na to. So this regarding sets and relation. No? So I think I have already previewed this already. So ito talaga didigin na tayo sa abstract. Do sana naging theory of numbers. Wala ka pa theory of numbers, no? Michaela?
Wala pa po. Next sem ko pa kumukuha.
Next sem. Sino kaya ang prof mo doon? Si Sir Job kaya? Mas kaugnay siya ng ano eh, ng set theory, yung number theory. So ito, let's look. Nakikita mo, can you see clearly? PDF kasi, hindi ko pa siya na-convert sa ano. Okay lang? So mathematics is study of ideas, not just numbers. Though it's numbers is the application. So theoretically, it's the ideas that we are studying here. The principles behind, the actions, the postulates, the corollaries, the theorems. No? The idea from modern algebra. By the way, the other term for abstract is modern algebra. Now they're using the term modern algebra to denote abstract algebra. Kasi nga masyadong abstract yung salitang abstract algebra. So which focus on the group, no? Group theory. Kaya nga meron tayong group theory na may makikita kang ganyang branch of mathematics, group theory. Ano ba yung group theory? So ito yon. So parang yung cluster siya ng ano, meron siyang ring theory. Meron kang other theories, no? Here. Now we will use numbers to give examples of groups. But the topics covered in modern algebra are abstract ideas of groups, rings, and fields. Kaya meron kang group theory, ring theory, and field theory, all of which is part of the umbrella of what we call abstract algebra. Ayan. So yan. So sometimes we call it yan, yung mga elements na yan, we need to define something here. So elements would be part of a group. It could no particular order perhaps. So therefore we would write a set of elements in any of the following forms. Ayan, papasadahan ko lang to kasi some of this had been already discussed under your set theory. So if A is an element of S, we could write A element of S. That's what we have studied a while ago. S is the set with no elements, meaning empty set. Or sometimes, ang ating pag-drawing dyan, yung ating empty set, no? Yan, yung empty set natin. Ganun, gumaganon, no? May problema talaga itong mouse ko. Siguro mouse ko nang problema. Yan, yung empty set. Yan. So, okay ba? So, unique factor lang to. So, empty set. Or sometimes we call it null set. So, there are some definitions. No? Sometimes, we need to structure doon our definitions. So, yan. Yung sa set theory natin, so, A is, a set B is a subset of set A as denoted as B subset of A. Or depende kung saan nakaturo yung set, no? So, ibig sabihin, mas malaki yung A sa B. Ito naman, malaki. Or it could be A, which is a superset of B. Parang ganun, kung babaliktarin mo siya. So, A, B subset of A, or A superset of B. So, pero pareho lang ibig sabihin yan. If every element B, element of B, also an element of A. So, walang mga additional element outside of A. So, B is a subset of A, not equal. They're not equal. No, kasi pwedeng siyang maging equivalent. And then we write B subset of A, or yan, o simply wala na yung equivalence symbol na yan. Kasi possible yan na subset at the same time equivalent. Anyway, two equivalent sets are subsets to each other. So, ayan, for any set B, empty set is a subset equivalent of B. So, empty set is part of the set. Alright? It's part of the set. Note now we could show A and B are equal, showing that A is subset of B and B subset of A. If they are subset one to another, they are equivalent or equal sets. And sometimes we call it, if A is any set, itself is an improper subset of set A. All other subsets of A are proper subsets. And what yung empty set is a trivial subset of A. Yung sarili niya, improper subset niya. And the rest is all other proper subsets. That's not equivalent to A.
Sir, ano po ulit yung symbol sa improper subset po, yung wala pong line sa ilalim? Ay, yung may...
Hindi kailangan symbolize yung improper sa proper. Nagkakatalo lang siya sa definition. Pag improper mismo, siya rin yung set. Siya mismo yung set. Diba, set A, improper subset of itself. Pero pag sinabing proper, something less of A. Halimbawa, A contains 1, 2, 3, 4, 5, and then meron kang 2, 5. Yung 2, 5, proper subset of A yon. Pero kung yung 1, 2, 3, 4, 5, i-relate mo sa A, improper yon kasi nga, A din yun.
Pero wala po siyang symbol, sir.
Wala. You don't need to, basta proper or equivalent. Magiging equivalent siya pag improper. Equivalent.
So kapag ka proper subset po, yun po yung wala
pag
po.
Proper subset, yung walang equivalent, walang dash. Proper kasi a little, it should be a less than of the set. Yun yung other subset of A are proper subset. So meaning, hindi yung kabuuan ng A, less of A is proper. Parang yung proper fraction, di ba? Saka improper. Ayun lang, mali lang, iba lang yung gamit ng improper doon. Kasi yung improper, mas higit doon sa whole number. Pero yung proper, it's always less. Proper fractions. Di ba? Parang ganun din siya, yung proper subset. It's always less of the set. Pero yung improper, it's the set in itself. Okay? Parang ikaw ay set ng sarili mo. Yun nga lang, improper yun. Improper siya. Okay? Gets ba? Okay, so mayroon tayong mga universal set, no? In axiomatic set theory, we have universal set. All sets we discuss are subsets of what we call universal set, or sometimes we call it U. Yung malaking U, no? So alam kong symbol dyan eh, yung ganun. Tama ba, Micaela? So yun normally, dun sa Venn diagram, I suppose, naalala mo to, meron kang U. Universal subset. Tapos meron kang bilog dyan. Yan, yung mga set. Yan. O, di ba? Pero yung rectangle na yan, that's a universal. Representing the universal subset. Okay? So, yan. For example, we can let universal set be set of natural numbers. So, that's an infinite number of sets from 1, 2, and 3, etc. But we could define a set. No, indefinite yun, pero we could define set A out of the subset of a universal set that has indefinite elements. Now, we could define set A such that, no, X would be element of natural numbers, whereas X squared is less than equal to 100. So meaning positive numbers that is less, whose squared is less or equal 100. So that would connote the elements 1 to 10. So because 1 to 10, when you square it, it's less than or equal 100. All of which are elements of a natural number. Siguro familiar kayo sa mga symbolism ng integers, no? N is natural, Q is rational, R is real, Z is integer. Di ba? Na-mention ba yan sa set theory or not necessarily? Okay.
Parang hindi. Pero medyo familiar po.
Familiar. Okay. So ito yan, ito yung gagamitin natin all throughout, no? So may konting difference sa first presentation, pero halos pareho lang naman. So you have natural numbers from or the counting numbers, I would say 1, 2, 3, whole number that would include 0, and then integer Z from the German word Zahlen, meaning number, and the rational number Q, whereas P over Q, whereas P and Q are elements of integers, and Q is not equal to 0. And then R, of course, is real numbers. That corresponds to rational and irrational numbers as well. And then we have the complex numbers, both real and imaginary. Okay, so yan yung parang domain, yun yung mga symbolism na gagamitin natin or somewhat notations. So these are the notations that we will be using throughout the course. Okay, some subsets of the above set of real numbers are important. So particularly, we have positive integer. Pag positive, so we will just put a plus sign, no? Z, plus. Positive integers, positive rationals, and positive reals, respectively. So to give an emphasis to these proper subsets. Or sometimes we call it non-zero. Pag non-zero naman, we denote it as sige, no problem. Matagal na ba tayo nagdi-discuss? O nga, no? May 2 oras na pala. Sige, go ahead. Just alert me when you're back. Siguro coffee break din ako. Saglit lang. Coffee break din ako. Okay na. Micaela. Kape muna, kape.
Okay na po.
Okay na? O, kape saka burger. Eh, binala na ako ni Mrs. Eh. Sabi niya, tagal-tagal mo naman nag-lecture. Oo, kailangan ano talaga. Ayan, ano ba tayo? So ayan, no? So dinidenote naman natin yung mga non-zero as asterisk. Ayan, at least ngayon medyo alam mo na yan. Pag lumalabas talaga sa board, Micaela, itong mga symbols na to. So you take note of this. You take note of that. Mahina siguro signal ni Dale, di na magparamdam eh. Sa YouTube, wala rin siya. Oh.
Malakas daw po ulan po sa kanila.
Ganun ba? Kumusta dyan sa inyo? Maulan ba or dito kulimlim lang konti, yun lang.
Maaraw po.
Maaraw.
Maaraw po pero may hangin.
Makulimlim lang ng konti. Anyway, so ito, no, yung yung asterisk natin, these are non-zero. Non-zero yan. Okay? So we notice here that integers, non-zero integers is a subset of rational numbers, and the rational numbers that are non-zero is subset of the real numbers, and the real numbers that is non-zero is subset of the complex numbers. Same as true with those without symbols, no? So pare-pareho lang siya. Ganito siya yung pagkaka-subset. Integer, rational numbers, real numbers, complex numbers. Okay? So another definition. Konti na lang to. Micaela, I know you're getting tired. Mahirap ba maging math major, Micaela?
Opo.
Oo naman, kasi nga, kailangan paghirapan natin to, di ba? So, kailangan paghirapan. Everything, even yung mga English language major, though hindi naman sila computational talaga. Saka hindi nila masisense yung hirap ng pigain ng utak sa numero. Samantalang sila pabasa-basa ng literature, grammar analysis, syntactical analysis, mga ganun, mga diction. Kaya ano naman natin yun? Tayo kumakain ng numero, sila kumakain ng letra. Talagang may ano. Though hindi natin sinasabing mas magaling tayo sa kanila. Mas magaling tayo sa mathematics, syempre, kaya tayo naging math major. Talaga, syempre, ano rin naman yun. Deserve naman natin na ano, after all of the sacrifices. O, di ba? Yan. Kailangan talaga may tawag nga dyan, perseverance. You need to persevere so that at the end of them all, no, you will be, those who persevere with Christ will also be glorified with Him. O, di ba? Ayan. Same as true with our studies. Application din yun. Now, of course, if you would like to see the glory in your profession, you must first have these moments of suffering, so-called, in the studies. Hardships, yan, endurance. So, yun yung mga panawagan sa atin. Alright, so ito, so we have A and B are sets, set A times B, whereas, or such that A and B, elements A and B, such that, no? Itong slash na to, such that A is element of A and B is element of B. So that's what we call Cartesian product A and B. Parang cross product to. I don't know if you still recall cross product saka dot product. Naalala mo ba yung sa linear algebra? Meron tayong cross A cross B, meron A dot B. No, pag dot product lang, scalar product lang yun. Naalala mo na sa linear algebra? Scalar product. Samantalang itong A cross B, that is vector product. Naalala mo na? Yeah, sa linear algebra. Pero ginagamit din siya sa sets in relation. So pag krinos mo yung product, all probable sets or pairs that we may think. So for instance, 1 to A, 1, 2 and A, 3 and A, 1 and B, 2B, and 3B. So yan yung mga possible, probable. Kasi nga, 3 parang 3 times 2 yan eh. So ibig sabihin, kung may 3 elements times 2 elements, what will be the expected sets of elements? 6 elements, 6 pairs of elements. So ganun yung mga ano na yan. Okay, meron namang ganito. Aside from the Cartesian product, so that's the Cartesian product. Then there's a relation between sets A and B. Is a subset R of A cross B. Obviously, that A and B are elements of that R or relation. When we say that A is related to B, denoted as A related to B. So, kaya yung ganyan, of course, we have, kumbaga, yung subset, no, yung kung anong nandito sa cross, yun yung element, no? Yung subset na kukunin natin sa A cross B. So, if R supposedly is on this subset, then we have 1 relation to A, 1 related to A, 2 related to B, and 3 related to B. Okay, ganun yung makikita natin diyan na readings niya. Okay? So, these are just, anyway, upload ko to, wag kang mag-alala, upload ko agad to. Para may, tapos yung entire text, hindi ito yung buong text ng libro eh. So, i-upload ko rin siya. No, both the lecture and the chapter itself. No. Alright. So, and then we have the function P is mapping set X into set Y in relation between X and Y such that X element of X appears to the first member of exactly one ordered pair X and Y element of P. Then we may also call the function a map or mapping of X into Y. Or perhaps we could write X into Y. So yung directional na ano dito, X into Y. For X and Y pair is an element of P, Greek letter P. Therefore, we could write that P of X is equal to Y. Parang F of X lang, no? Is equal to Y. Parang ganon, no? Kaya nga yung domain P, the domain P is the set of X, and the codomain, sometimes we call it the range. The codomain is called the range. Doon nakuha to. Yung college algebra natin na range and domain, dito nakuha sa abstract algebra or sa set theory. So dyan yan. Kaya mas matanda ito eh, kung tutusin. Yan, codomain or sometimes we call it range. The range of P of set P of X. Such that P of X, whereas X is element of X. So yun yung ano natin dyan. Okay, note we use square brackets when applying to a function. The idea of a codomain is to tell the type of object which is given out. No? Kapag function, so ang ginagawa natin ay bracket. Pero pag yung element of the function, pair of parentheses. Yan yung pagkakaiba niya. Ayan, for example, if we treat multiplication of column vector of dimension n, be an m by n matrix. Ayan, applied to linear algebra. Then we get an m-dimensional vector. So the codomain or the range is r raised to m, depending on the row times column to it. Although the range may be proper subset of r raised to m. Okay, so siguro example exercise, no? Tingnan natin. Ito na lang, exercise 1.2. So which are functions na ipa-function which is 1-to-1 and which is on-to. Parang yung kanina, parallel ito sa kanina. So kung A to B, so ano siya? 1 corresponds to 2, 2 corresponds to 4, and 3 corresponds to 6. So there is a function. It's a function. Because there's a 1-to-1 correspondence. It's a function. Ito naman, 1 to 6, 1 to 2, and 1 to 4. It's not a function. No, it's not a function because there's no one-to-one correspondence. And then 2 on 2, 1 and 6, 3 and 4. It has correspondence, it has a one-to-one, and it's also an onto. An onto. Di ba pag sinabi natin onto, lahat dapat ng B, nasa B, may correspondence dun sa A. No, though not necessarily, pwede siyang multiple variable sa A, may correspondence dun sa B. Pero lahat dapat ng B kasama doon. No, walang may hiwalay. That's onto. And it's also a function at the same time. Okay. Two sets X and Y have the same cardinality if there exists one-to-one function mapping of X onto Y. So may one-to-one mapping ka. So for every element of X, there's a corresponding element of Y. That's what we call one-to-one correspondence between X and Y. And that's what we call same cardinality. Di ba mayroon tayong same ordinality? Pag ordinality naman yung order. Yung cardinality, yung element, yung corresponding element ng function X at function Y. Okay? Kaya doon na-derive yung salitang cardinal number. Tama ba, Minakaela? Ordinal versus cardinal. Cardinal is more on the elements itself. Ordinal corresponds to the order of the number. Kaya siya ordinal. Pag cardinal, yung cardinality o yung size ng set. Ayan. However, surprisingly, there are different levels of infinity. Ayan, the smallest level of infinity in the cardinality of n or natural number is denoted as aleph, naught. So yung sub-zero dito is naught or zero. We denote cardinality of set A as absolute value of A. So meaning there is naught. Aleph naught corresponds to the absolute value of natural number, absolute value of integers, absolute value of rational numbers. Of course, this is not equal to real numbers, but also for, tingnan natin bakit siya ganon. So there must be a reason behind this. Okay, yung partition, ano na to, na-discuss na natin to kanina. A set of cardinal naught, aleph naught is called countable. So R is not countable. And real is, binanggit dito, real numbers form an infinite set larger than the infinite set of natural numbers. Okay, anyway, so that could be a reading na lang. Partition, we have discussed this already. Equivalence relation, na-discuss na natin ito, Micaela, kanina, yung reflexive, ito na yung parallel, reflexive, symmetric, and transitive in terms of relation. Iba lang yung connotation niya, pero pareho lang. And then, saka pumasok ang tinatawag natin na division algorithm, na-discuss na rin natin ito kanina. Pati yung modular arithmetic. Ayan, so basahin mo na lang yung reading, pati yung equivalence relation. At alam kong alam mo to, Micaela, yung truth table. Oh, alam mo pa to, Micaela, alam kong hindi mo makakalimutan to eh. Tama ba? This from your logic, no? Logic tables. Alright? So, yan yung ating ano dyan. So, ito na lang, more on readings mo na lang to. Supplementary readings na to, pero part pa rin siya ng text. Ayan. So, PQ, PN. Tama ba? P and Q, P or Q, P implies Q, not P, not Q, not P, not PN, not Q, not P or, or not Q, and then Q implies not P. So, ayan yung mga truth table na yan. No? So, hindi ko na di-discuss to, Micaela. Alam mo paano i-derive to. Tama? Yung mga truth tables na yan. Alright, so yan yung ating maikling introduction, supplement. By next week, ayan na. So we will be looking into, papakita ko na rin sa iyo. Though i-upload ko ng pareho. No? Ayan, groups and subgroups na tayo. Ito na yung ating di-discuss. So do meron pa akong mas anong text, no? Mas yan, mag-di-discuss tayo ng konti ng fundamental theorem of algebra. Pag sinabing groups, may konting derivation. Ayan, yung madi-discuss din natin. Kaya tama lang yung complex kanina. Overlap lang ng konti itong text na to. So, di-discuss natin yan. Binary operation. So, alam ko sa theory na-discuss to. Tama, Mikaela? Binary operations. Ayan, yung mga binary operations na yan. So, we'll discuss that also. What else? By the way, I have seen a book that could be useful to us. Papakita ko rin lang sa'yo. Doon nagsisisi ako dahil doon sa yung previous book natin pang graduate school yon. So baka hindi mo na yung so medyo pang ano siya, isomorphic binary structure, yan. Pag-aaralan natin lahat yan. Huwag kang mag-alala, we will be in detail with this. Though minsan kailangan kong magmadali din. So papakita ko sa iyo yung isa pa nating reference text. No? Ito, first course in college in abstract algebra. This is the 8th edition by John Praley and Neil Brand. So nasimulan natin yung sets relation kanina. Ito na yung diniscuss ko. So pero ito mas tedious to. So may mga exercises na siya. So pipili ka na agad diyan ng exercise, Mikaela, yung siguro ilang kaya, depende kung ilan. Siguro 10 uli, 10. Basta kada upload ko may nasa dulong exercise 10. Pili ka lang ng 10. Okay, anyway, ayan, halos na discuss na natin to. Pareho lang dun sa nakaraang reference. And then ganun din yung part 1, yung groups and subgroup. I-upload ko na rin to. Ito yung exercises dito. Depende kasi sa arrangement niya, no? So pag-iisipan ko pa tong part 2, pero tong part 0, ayan, pili ka uli ng 10 dyan, yung exercises dyan. Dito. Anyway, I will upload it, don't worry. I will upload that. Maybe tonight. Okay? So, you have clarification, Mikaela? So far, yun, medyo minamadali ko rin to para at least makasampa na tayo dun sa actual abstract algebra course. Yan, para makasampa na tayo dun. Okay, some thoughts. So, kailangan mo talagang magbasa. You need to read and the theorems. Though, I will not be rigorous in proving. No, kaya yan, pinapatake ko na lang sa'yo, yung kung anong mapili mong mga problems yan. What I will be discussing is just the sample concepts, very important to establish the concepts and to provide some techniques in solving and proving. And of course, from time to time, I'll be getting some references and then we will try to solve it even manually or through Octave. May mga kaya namang gawin ng Octave, even in abstract algebra. No, katulad nung demonstrate ko, yung GCD, LCM, yung modular arithmetic, kaya niyang gawin yun. So, pwede rin siya sa iba pang mga processes na madi-discuss natin throughout this course. Okay, Mikaela. So far, you have already 10. And then, my next upload, you choose another 10. Madadali lang naman siya. Hindi pa siya yung tedious talaga. Kasi kailangan mo lang dyan ng concept ng mga set theory and others. Okay? So, yun lang. And then yung mga susunod kong upload, siguro puro tagsa 10 lang. Hanggang yun na yung submission ko by entire, and then I'll try to construct a multiple choice question that is somewhat also let possible questions also for abstract algebra. Though mangilan-ngilan lang yung tanong sa abstract, pero mahalaga masagot mo pa rin yun pag nasa board exam ka na. Okay, so some clarification, Micaela. So you could just read the material. I'll be uploading the soonest time as well, and then you choose your problem na lang. Okay?
So yung buong book ba yung i-upload nyo po or yung...
Yun lang munang portion. Yung portion na yun. Yung chapter 0 ng book na yun, saka yung chapter 1. Yun lang muna i-upload.
Pero po yung exercises po.
Oh, dun sa dulo, yung exercises. Parang yung katulad nung yung previous upload ko, di ba? Exercises lang siya nun. So, ganun din yung i-upload ko mamaya. Pipili ka lang ng 10.
So, dalawang chapters na po yun? Yung 0
Oo, magkasunod, actually magkadikit yun eh. And then, sunod-sunod na yan.
Okay po.
Magpa-pile up na siya. Minsan kasi, magdi-discuss tayo ng maraming topics per week. So, marami din akong i-upload. So, patong-patong na siya. Kaya, at mas possible, matapos mo na rin within the week yung pinili mong 10. No, para do hindi mo muna siya ipapasa, tapos muna siya para mag-focus ka na dun sa susunod na 10, etc. etc. So, ganun siya. Okay?
Opo.
Sige. Thank you, Micaela, for your copy muna tayo. Thank you for, I know this had been an exhausting day. But from time to time, I'll be throwing out questions. So, you just be ready. I will be throwing out questions based on the readings. Katulad kanina, yung may mga trinaw akong questions. So, dapat, medyo alert ka lang doon sa mga questions natin. Okay? So, parang lang yan, probing ko lang yan sa'yo. Though I know naman na binabasa mo yung mga materials nila. Alright, so let's close in a word of prayer. We thank you, Lord, for your mercy and grace. Thank you for sustaining us, even though this topic is exhausting us, Lord. Our energy, most especially Micaela, and how she absorbed these topics, a broad topic regarding integers, number theory, set theory, as it is related to abstract algebra. And we thank you, Lord, because you sustain us. And I hope and pray that you may continually guide us, even as we have a diligent study of this course. I pray, Lord, for your protection to Micaela, also with Dale, for whatever reason that he may not connect to this afternoon. I pray also for your grace and sufficiency to his ministry. We thank you, Lord. We honor you. Bless us, Lord, as we continue to serve you and glorify your name. This is our prayer in Christ's name. Amen. Okay, Micaela, thank you. And see you tomorrow. So we will have, ano bang meron tayo? Edu 115, no? Tama ba?
Opo.
Okay, bye-bye. God bless.
Thank you po.